All right, we are going to be graphing some linear equations. There's three different ways to go about graphing these things. One of them is taking an equation and making a table of values. That's probably the most inefficient way of doing it. There are some shortcuts. One of them is graphing using intercepts. So if we can find the x-intercept and the y-intercept, you really only need 2 points to plot a line to create a graph. And these are linear equations, so they're all going to be lines. That is a method that's probably not used all that often. The most common one is kind of the y equals mx plus b, doing the slopes and y-intercepts. But we are going to show the x-intercept and y-intercept. Some people may like it, and it can be pretty fast and efficient, but it's probably not the most commonly used one. So to do x-intercepts or intercepts, we really need 2 points. So we need a minimum of 2 points. That's kind of the idea behind this. Okay, so here's the biggest thing that we need to figure out. How do you find an x-intercept? So if we are talking about a graph and you're talking about any point on the x-axis, they all have something in common, and it's the fact that you have some x value and the y value is 0 on every single one of those. So something comma 0. Okay, that's the biggest thing, is there's no height because you're on the x-axis. So how do you find an x-intercept? Every single x-intercept is some number comma 0. So if we know that the y value has to be 0, we plug in 0 for y. Then solve for x. All right, so why this is not a bad method is because plugging in 0 is pretty nice. How do you find a y-intercept? Well, any point that's on the y-axis, they all have something in common, and it's the x value is 0 because there's no left and right associated with it. So you're looking at every single y-intercept at 0 comma y. All right, so same idea. Plug in 0 for x this time, then solve for y. Okay, so let's see it in practice. So if you're looking for the x-intercept, you're looking for an x value with a y value of 0. So our y value is going to be 0, so we're going to do 2x minus 3 times 0 equals 6. So the y value became 0. And we'll do this math. This is just basically going to go away, so it just becomes 2x equals 6 divided by 2, x equals 3. So we are looking at a coordinate of 3, 0. So we plot that point. All right, same idea for the y-intercept. Y-intercept is going to be 0 for the x. We don't know the y. So same thing, we'll take this equation, we're going to plug in 0 for x. So it's going to be 2 times 0 minus 3y equals 6. And there's the rest of the equation. So the 2 times 0 goes away, and you're left with a negative 3y equals 6 divided by negative 3y equals negative 2. So our coordinate is 0, negative 2. Plot that point. And since it's a linear equation, because there's no exponents or anything on these x's and y's, it's just going to be a straight line. All I need really is 2 points to plot it. And there's a rough sketch of my graph. Okay. So we'll do one more. So to do this, we're going to find the x-intercept. So let me just kind of organize my stuff. So the x-intercept is going to be, again, our x value, we don't know. The y value is going to be locked at a 0. So if I plug in a 0 for y, we get 0 equals 7x. Divide by 7. 7's go away, so x is by itself. 0 divided by 7 is 0. So our coordinate is 0, 0. Okay, so that's our x-intercept. Let's do our y-intercept. Y-intercept is 0, y. So 0 for x. So 0 for that. Y we don't know. So 7 times 0 is 0, so y equals 0. Huh. Okay, so some thoughts on that. We're going to plot that point of 0, 0, but it's not only the x-intercept, but it's also the y-intercept. Well, that's not actually very helpful. It is, but we need 2 points. So, same point. So it's almost helpful. What we need one more. Well, to figure out our one more point, we're going to pick an x. Pick an x to plug in. So this just shifted to finding x and y intercepts to instead, we found an x, y intercept. It was one and the same, but we just need one more point. So the easiest is, let's just plug in x equals 1. If we could plug in 1, we'll find a y value for that. We'll plot that point, and that'll be our second point. Okay, so it's pretty rare that that happens. Most of the time, it kind of looks like something like this or something like this, and you get an x and a y intercept. Sometimes you don't. You only get a point. And so then you just have to kind of go the extra step to figure out one more point. So if we plug in a 1, so our y value is going to equal 7 times 1, which means our y value is 7. So then our coordinate is we plugged in 1, we got out 7. And so I plot that point. 1, 2, 3, 6, 7. Okay, and then it's pretty steep. And that is another point, so we can connect the two and make ourselves our line. Okay, so that was drawing a graph with x and y intercepts, but also showing that there might be a hitch in that kind of a process. Okay, and then the next method will show of doing a slope intercept form where the y equals mx plus b, which is probably the one that most people are familiar with and most people choose to use, because then you don't have to worry about these kind of weird situations like that. Okay.